are Team LunARC from Embry-Riddle Aeronautical University, talking about our proposal for the NASA Luna Recycle Challenge. Our plan is to recycle plastic bags and cotton undergarments in combination with lunar regolith to produce a substance colloquially known as lunar concrete. The plastic bag is used as a binder, and the cotton serves as a reinforcement analogous to rebar's role with earth concrete. Lunar concrete has a multitude of potential lunar infrastructure use cases, including but not limited to lunar habitats, landing pads, and radiation shielding. The idea is based on a combination of previous experiments and research papers on reinforcing lunar concrete with fibers. The ideation of this project spurs from a proof of concept previously done by one of the team members. In this previous experiment, there were differences in binder and specific mix of fiber reinforcement. However, it largely supported the idea that reinforcement with fibers would increase the structural integrity of lunar regolith-based concrete, even under freezing and heated conditions. Research papers were also found that supported the idea that polyethylene could be used as a binder for a lunar concrete, and that fiber reinforcement, although in the form of basalt or human hair fibers, would also increase the strength of lunar concrete. Based upon these papers, the proposed process of manufacturing lunar concrete will lead to an increase in its strength.
Our team has done research into processing our materials and has come up with solutions for transforming our input materials into intermediary materials. First is converting plastic bags into polyethylene powder. For this, no conversions are needed as plastic bags are already made in polyethylene. Therefore, all that needs to be done is for the bags to be shredded and turned into small pellets. This can be achieved through a combination shredder agglomerator, which shreds and turns the plastic into small pellets, the output of which can be made into finer particles with a knife shred. Second is converting cotton into usable fibers. To increase the strength of the fibers, we first treat the cotton undergarments in a process known as mercerization. This essentially just makes the fibers rounder and more uniform, which increases the tensile and compressive strength of the fibers. Then, these mercerized shirts need to be broken down into cotton fibers. This can be done manually by pulling apart the cotton fibers, and it can be automated with a fiber separation machine. This creates usable fibers to be mixed in with the lunar concrete mix. To test and refine our lunar concrete mix design, we have a manual hydraulic press, which we can use to produce and then test the lunar concrete. This will help us ultimately determine the optimal mixture to maximize strength of the concrete. Once optimal mixture is determined, it can be used to establish ultimate batch size and further familiarize the team with production and any safety concerns when scaling to industrial production.
The team has also begun preparation for an industrial scale recycling machine. A model has been developed with an emphasis on near full automation and material efficiency. This is done using a combination of pre-built components and in-house design components. CAD has begun on some of these key components, including mercerization machines, mixers, and custom press systems. These components will be used in 4 main subsystems, which consist of mercerized cotton production, polyethylene production, mixing, and lunar creation. Ultimately, this leads to a model having an estimated power usage of 4.84 kilowatt hours per cycle, a production cycle of 204 minutes, ultimately leading to an output of 1.229 kilograms of lunar feed per hour.